Welcome back, viewers. Operations are all about. Now on your screen you can see that a binary operation is a simple rule, of course, that will combine two values at a time to produce a single value. A binary operation, the word binary means two. Operation is just a rule, a pattern, a laid down approach where something is to be done. Alright, so a binary operation is a simple rule for combining two values at a time in order to produce a particular value. Alright, so I might have something like, let's say I have two operands A and B. I have two operands A and B and my operation is star. So I can say A star B is equals to something like A square minus B square plus 4. That is a simple rule. That is now a simple binary operation. That anytime I have two operands A and B, I'm to square the first operand minus square the second operand and add it to 4. So if I were to evaluate something like 2 star 1, for instance, 2 star 1 now means A is now 2 and B is now 1. So A square now becomes 2 square minus B square now becomes 1 square. Then I now add 4 to that. So this is equals to 2 square is 4 minus 1 square is 1 plus 4, which is equals to 4 minus 1 is 3 and 3 plus 4 is 7. So combining 2 star 1 with the laid down simple rule of A star B has given us a new value, which of course is 7. So a binary operation is simply a rule that will always combine two values at a time to produce a single value as the answer at the end of the day. And on the screen you can look at the properties of binary operation, which of course I have already explained some of them in the previous session. Alright, the first property here we have is the closure property. Now what closure property means is that if I pick two elements from a particular set and carry out a particular binary operation and the answer I have is also an element of that set, then that operation is said to be closed as far as that set is concerned. Don't forget what I called the natural numbers earlier as 1, 2, 3, 4, 5, 6, 7 till I get to infinity. If you pick two natural numbers out, let's say 5 and 10, 5 plus 10 will give us 15 and 15 is still a natural number, then the operation addition is said to be closed as far as the natural set is concerned. We call that the closure property. So closure property in a nutshell means that anytime you pick out the operands from a particular set, you carry out a particular binary operation on them and the answer to that operation is also an element of that particular set, then the operation is said to be closed as far as that set is concerned. So if I have a binary operation as star and I take out two operands out of a particular set. Let's say I want to operate star on a particular set of numbers, natural numbers or integers, and after operating star I notice that my answer is also an element of that particular set where I pitch the two operands from. That operation is said to be closed. That explains closure property. So addition is a closed operation as far as natural set is concerned. Multiplication is also a closed operation as far as the natural set is concerned, because if you pick two natural numbers out, 2 times 5 multiply, you have 10, which is also a natural number, so the operation is also closed. If you look at something like subtraction, 2 minus 10 will give you, even when 2 is a natural number and 10 is also a natural number, 2 minus 10 will give you minus 8, which is no longer a natural number. So subtraction is not closed as far as the natural set is concerned. And mind you, when you talk about closure property, it must be commutative. So you cannot just say 10 minus 2. You have to look at it the reverse side. 2 minus 10 and 10 minus 2 also, before you can conclude if an operation is closed or not. Alright, commutative property is what I've already explained. If an operation is binary and is called star, and A star B will give me the same answer as B star A. That's if I interchange the operands and the answer is still the same, that operation is said to be commutative. You can refer back to the previous video, which is what I did earlier. You really understand commutative property. based on what I have just said now, that if you interchange the operands of an operation and the result does not change, then that operation is said to be commutative. Of course, distributive is when you open a bracket up, you have A star into B star C, and it's the same thing as, I think I explained that, but let me do it again. If my binary operation is star, so I have something like A star into B star C, and this is equals to, I take the first two element first, A star B, then finally star C. If this answer gives me the same thing, then that operation is said to be associative. Alright, now distributive property is when an operation can open up another operation in a bracket. Let's say I have two operations, star and delta. So I have something like A star into B delta C, and this can open this bracket as A star B first in bracket, then delta A star C, A star C. If I define two binary operations as star and also as delta, and this bracket is true, that means star can open this up, then we say that star is distributive over delta. That is, the operation star distributes over the operation delta. Don't worry, in the next video we'll be solving a lot of examples and you get to understand what I mean by all of this. Okay, the next of course is the identity. If A star E is equals to A, then E is called the identity element of that operation star. Don't forget, 2 plus 0 gave us 2, making 0 the identity for 2, and 2 times 1 gave us 2, making 1 also the identity. If an operation is star and maybe I'm asked to find something like the identity, I'm going to define A star E to be equals to A, making E the identity. Meaning if I operate E with A as star, the operation is star, and the result returns A, E is now called the identity. And of course, the inverse property, if I have A star A inverse and it's equals to E, then A inverse is called the inverse of A as far as the operation star is concerned. Don't forget, 2 minus 2 gave us 0, making minus 2 the inverse of 2, talking about additive inverse, and 2 times 1 over 2 gave us 1, making 1 over 2 the inverse of 2, talking about multiplication. So if I have an operation called star and A star something gives me E, which is the identity, then that means that something we were using is the inverse of A. Ladies and gentlemen, that has been our session on binary operation, which of course in this session I've established what binary operations are all about. Of course, I have told you that a binary operation is a simple rule that will always combine two values at a time to produce a single value. And of course, I have discussed the properties of binary operations as closure property, commutative property, associative property, distributive property, identity property, and of course the inverse property. In the next session now, we'll be solving a lot of mathematical problems involving binary operation. Of course, that session is going to be one of the most important sessions for you, because I'm going to be showing you how to use all these stories I have fed you with to be able to answer mathematical problems involving binary operation. Make sure you don't miss the next video.